have you been thinking about automation? Do you want to take your OEE from 50, 60% to maybe 85, 90%? It is possible. Let's find out how. Matt, tell me how.
Right, well, we've got robots as an obvious solution to that, and that's something that we must emphasise a lot of people don't take into consideration in the UK, is that putting robots into a solution with machine tending will give you that extra efficiency gain, and that's where the big payback is. And looking at sort of the system we've got here, this customer is a good example of how that can help. So we've got a robot with a vision system. Vision system is very, very flexible in giving the ability to put many, many different parts in. One thing that customers don't always realise is quite how much efficiency they will gain. And it's something we constantly get from customers coming back and saying, we didn't realise how efficient the system would be. We're doing what we did in a week in 3 days. That then gives you spare capacity. These systems with the vision system, it gives you that flexibility that you can add an extra part or an extra job onto your existing cells, getting more production and almost for free.
So it's not just about having a big batch run running sort of 24/7, 7 days a week. You can do different batch runs all the time. This system allows for that.
Absolutely, and we've got customers with 300-400 different components they put through their system. Here we're running, I think it's a variety of about 5 different components, and that works really well for these guys.
Now, I can buy a robot off the shelf, and that's what your system is, but you need a system integrator as well?
Yeah, absolutely. I mean, what we supply, it fundamentally are the core bones of the system. So if you like, a toolbox for automation machine tending. And we work with various integrators. DEM is a very good example of an integrator that specifically specialises in machine tool tending. So they bring to the party all of that expertise and knowledge of machine tending, and we bring the hardware and the clever bits, if you like, the clever toolbox of kits that they can use. So it's important that you get that integration, that seamless integration, so that you don't get the problems that can fall between the cracks.
Okay, so in very simple terms, sounds like you're providing that robotic solution. DEM turn up basically with a big Meccano kit on the day, getting it all running and streamlining that process, and one person to deal with.
Absolutely, and it's important to say absolutely all the bits of the jigsaw puzzle come together and it all goes through, and to the customer it looks really seamless, but what we don't always see is the work that goes on in the background to make all of that happen, because ultimately when we're on a customer's site, the last thing we want to be doing is there for months on end trying to get the thing to work. So it's important that you tie up all those bits so that anybody can go and buy a robot, a camera, all those individual bits of kit, or there are standard options on the market where you can buy it and you can try and integrate it yourself. But the efficiency gains that you get from reduced downtime and from the increased efficiency and flexibility you get with a engineered solution from an expert, someone who's done it, been there and knows all the parts and all the difficulties and challenges that you might face, that's where the value is.
And you mentioned in terms of DEM, their expertise as well, providing a solution, but they've got engineering background as well. So I think best to do is go and find out what they actually do as a solution. I've decided to go the automation route, so I come to you guys. Tell me, well, the process, where do we start?
Yeah. Well, what we need to do, we need to get a full understanding of what you need. We need to look at components, we need to look at volumes, cycle times, additional operations. We've got to start with knowing what the end product is and where you're starting from. From that, we can then develop a solution around that particular process.
And my first thought is, and I mentioned this to Matt, does it have to be big hundreds of thousands of batch run?
No, not at all, not at all. Obviously, we need to see what the package is made up of, but when we have a look at the package, there's ways and means now of using technologies to actually to drill down and use a single source production cell to make multiple part numbers. It's all a case of sitting back, having to think about it and finding that solution to the problem.
How am I going to visualise this then?
Right, well, to visualise it, what we'll do is we'll sit down and get the basic production parameters off you as a customer. We'll look at your part, we'll look at the machine tools you're looking at using, we'll look at the different additional operations you've got, deburring, part marking and so on. We'll take that into a 3D world. So we'll sit down with our design team, we'll drop those machines into a visual representation, we'll drop your additional operations, and we'll start dropping whatever automation it is we need at that time, whether it be a robotic arm or whether it's another type of automation, to find out what size parts we need, what types of automation we need, and start seeing how the sequence is going to pan out and the space it's going to take.
And say I've already bought 2 machines, or you can advise on machines, or you can do either solution.
Yeah, of course. Obviously, we'd always like to advise on new pieces of kit because you've got a blank slate to start with. But yeah, you're using existing kit. We can talk with you, we can advise what interfaces or what modifications you may need to carry out. We can carry out certain modifications as well. We're not 100% governed by set interfaces. There's ways and means of us to hardwire and get in there in other ways.
So any machine tool essentially.
Yeah, pretty much.
Okay. And also to reiterate, your experience is engineering, so you'll know in terms of your milling and turning, whatever it might be.
Yeah, well, experience is in CNC machine tool manufacture. So yeah, milling, turning, 3, 4, 5 axis, whatever that may be. But myself, not only myself, but my team, we all come from an environment like what you see here today. So we've got the depth, we understand what outputs customers require for a finished part coming out of a cell. We understand then what automation has to give you with the person not being there, of how that output needs to come out of the cell. So we have the depth and the knowledge of making parts through this particular method to give you what you're after.
Okay, I think then what we need to do is actually look at some of the parts and how you brought it all together. Here we've got a cell with 2 fan outs, the customers already purchased these, but again, you can recommend which machines based on the component, is that correct?
Yeah, that's correct. Yeah, we can recommend what kind of machine tools, work with the customer right at the front end of the project. So we ensure that the whole thing comes together seamlessly.
Now, work holding in there?
Yeah, the work holding is also another part that we do here at DEM. What we do is we feel that work holding in CNC manufacturing world is one of the most vital components of manufacturing. If you haven't got hold of your part, then the rest of the process is at risk. So we keep that element in-house, we don't subcontract out. So when we're producing a cell, particularly in CNC, we're also producing the work holding, we also produce the grippers holding as well. So we design everything and simulate everything together to ensure we have a seamless integration when we turn up on site.
Okay, now I'm looking at that work holding though. You mentioned about hybrid manufacturing as well?
Yeah, the hybrid manufacture, as we call it, is we're now using additive manufacturing in place for certain components where we feel we can. Some places it has a place, some places it doesn't. But it allows us to sort of be that little bit more cost effective, that little bit quicker, depending on the amount of additive manufacturing we use on our work holding.
Okay, so for example, you've got your air sensors, machining those parts would potentially been expensive and take quite a while, whereas you could 3D print hybrid manufacture overnight?
Yeah, well, there's 2 elements that we use it for mainly. One is pneumatic channels for air sensing. Obviously with complex parts, particularly with castings, things like that, you need to get into strange places, you need to hook things around, and we also like to air sense in all axes as well. So we can very easily now, we can design and print more or less overnight very complex shapes with all the channels running through them to bolt to our fixtures. Whereas going through traditional manufacturing methods takes time. You've got design to come up with, you've got tools to buy, you've got programs to write. So it works and works very well for us.
You also mentioned the grippers as well.
Yeah, so we use additive manufacturing for the gripper assemblies as much as we can as well, where we deem it fit. So we try and make all bracketry that goes on the end of arm, we try and make all of the grippers attached to a 3D printer bracket, again using the 3D printing technology to use that bracket as almost a pneumatic manifold again. Allows us to move the air channels back in the bracketry to give a bit more freedom of movement at the end of the part. And we take that right through to the fingers themselves. Where it can be used on that particular component, we'll 3D print the fingers as well as the bracketry.
We've alluded earlier that it's not just about one component, you could multiple components. Is that an issue though with the work holding?
No, not at all. If we find we've got a cell where we've got multiple components, we'll try, wherever possible, to make one piece of work holding hold those multiple different types. Then using the vision system in the cell, automatically detect, using the technology, what part it is and load it into the correct position in the work holding and select the right CNC program in the machine. So for the people, it becomes seamless. You can lay a different part down each time on the conveyor, the cell will make the right part.
Two things then I want to ask in terms of, you mentioned about the hybrid manufacturing, which we've seen on the work holding on the robot arms. Do we do testing as well?
Yeah, we do. Everything we do is tested. Everything we run on a 24-hour burn test. We have a tool room and a test facility located back down at DEM, where we have a robot set up. We have test facilities for pneumatics, hydraulics. So all of our work holding is put on full test. We also then set the gripper assembly up, and we load in and out of every fixture prior to it ever leaving our facility.
But I mentioned about testing, but inspection as well?
Yeah, inspection we do. What we've done previously for customers is we've done detection of assembly items. Say a customer has a basic part with 5 or 6 different widgets in there of assembly items, call it. We've built bespoke little rigs using additive manufacture that holds sensors and picks up whether those parts are there or not.
But again, to keep it cost effective, you've used your hybrid manufacturing and 3D printing to do those fixtures.
Exactly. So throwing a part into CAD and then holding sensors around it, there's no easier way than then just casting up structures, printing the structure, bolting it together, and off we pop.
Making it sound very easy. Now, next thing, you want these machine tools. I mean, you've got 2 machine tools in this cell. You want them running 100% of the time, all the time if possible. I mean, that's maybe not feasible, say 95%. But the robot arm itself, that's going to be standing there idle for some quite, depending on obviously on the cycle times.
Well, it all depends down on the cycle times. But what you find is we'll always try and gear a cell up so it's working smoothly within the realms of the tack time that we've established at the front end. But what you do find on a lot of CNC automated systems is there'll be ancillaries, there'll be part marking, there'll be deburring, there'll be an additional blow off. And once you start adding in all of these pieces, you will always get a little bit of dwell time, which isn't always a bad thing. It means you're inside your total tack time, but you can cover quite a lot with a one arm.
Ultimately improving that efficiency.
Yeah, of course, it's all about efficiency.
So if I'm thinking, automation, I'm not 100% sure. What sort of return on investment can I get?
Obviously, it'll vary from program to program, but once you start rolling in the wage bill, once you start looking at your increase from, say, a manual OEE of 55, 65 to an automated 80 to 85, you're going to be getting more through less capex. You're going to be spending less to put the program in. Well, a general return on investment for an automated cell should probably be around 3 years, in my experience.
Yeah, 3 years, not bad though, is it?
Not bad at all.
And so if I'm thinking maybe just dipping my toe in, you've got almost a starter pack?
Yep, then we are looking at a starter pack at the moment. Not your wheel-up solution, there's already those on the market. What DEM are looking to do, we're looking to give you that basic starter pack, which will consist of an ABB robotic arm, a standard in-feed, with bolt-on ancillaries where you can bolt on part marking, deburring, blowing off, all of those standard little things. But we just want a small set of parts where you can gear up pretty quickly with 1 or 2 machines, lathes or mills.
So ultimately, again, giving one-stop solution for automation, taking it to that elusive 100% OEE, but getting very close to it. Thank you very much, Trevor.